My name is Felipe. I work at InternetNZ, and today the talk it's to show and to give you more context about our DNSSEC incident that occurred in the end of May of this year. So our agenda basically, I will introduce you in-depth big project that we had during the last year, and what happened related to that it's related to our incident. Talk a little bit about specifically of the incident, the cause, next steps, lessons learned. So basically, the operation teams behind the DNSSEC, it's little small, just 5 people that work in there that is responsible for all the operations behind the network, virtualization, the DNSSEC stuff. So the overview. In the end of the last year that I mentioned, we replacement our registry system with the new one. Was a big project, and in parallel of this project, we established more presence in new data centers, and we changed our network. Like now we are using EVPN with VXLAN, so a lot of change on this process. Another thing it's important to mention, we are using a multi-signer model 2. I think should talk a little bit about this yesterday, and we see what happened in our scenario. And our zonation process changed a little bit, the way that we are using to building zones. Basically, our zone generation process on the old style, we building our unsigned zones, inject some DNSSEC records, and we produce signed zones. We have 2 signers that it's synchronized with each other to have all the records there. And the way that we inject some records on the old register, it's a bit different on the new one that it's related to the incident. The incident specifically now, we start to do our first case key rollover operation after the migration of the new register system. We start to do with DNSSEC because it's our smaller zone with fewer delegations. Yeah, and problems start to be reported, but we cannot reproduce exactly the reporters are told us. We continue to do our rollover operations with the others second level domains, and we starting to see much more problems with that. We continue the investigation, but again, we bump at the same stuff. We cannot reproduce what we are receiving. And in the following morning, big surprise, or not a surprise, we start to see some media stuff related to this incident. Many users start to report different problems with that. And finally, we can identify the problem, we can reproduce. And the funny thing is that we can capture the problem in our internal infrastructure. So in our internal recursive server, we're starting to see the problems reported. So after this, what's a bit easier to determine the root cause. So we start to do a dump of the cache and analyze the logs. And this is some examples of what we had in our logs. The cause, finally, the cause it's very simple. It's TTL again. So in this case, one day it's very different of 1 hour. Just to summarize, in our road registry, I told you that we are injecting some DNSSEC records on the unsigned zones, but with these records was TTL. And in the new register system, we cannot specify TTL for DSs. So what happened is that in the new register system in the zone, these records inherited the default TTL of the zone, that in this case, it's 1 day. So what happened is you have a misalignment between the TTL on these unsigned zones in our policy of the OpenDNSSEC. And our policy of the OpenDNSSEC was prepared to sign in zones using 1 hour of the TTL, but the zones was 1 day. So what happens, we remove earlier the keys on the OpenDNSSEC, and the problem happened. So after that, we start to think in some options to take the course of action. One is to perform the site switch to another signer. So but this is another site, in another location, in new data center, in the new network that was untested, and we think that could be increase the risk and the problem that we are facing. Another untested procedure that we didn't have yet, it's recover the key that reached this dead state and try to back again to solve this. Of course, engage technical community to have a directed channel to help us to flush the zones and to capture more examples of the problem. And another one, just go and sign, but I think we're just thinking for 1 or 2 seconds. It's not really in our head, in our hands to remove the DNSSEC in our facilities, but I think it's important to show that this is an option, but I think we're never using this in this case. So because of that, we decided to wait to expire records and to start to communicate with the community the best actions to do. So we needed to do one last domain rollover. It's a .NZ. So .NZ have a different policy of the rest of the domains. So it's 1 day, it's correct. We don't have any problem with that. But because of the problem, we prefer to do some manual verification. So we start to communication between the public phase. We stop, we pause all the zone distribution, analyze each step that we are using, the injection in the DS in the DNS key, and all the process of to produce the zone. After that, we resume the operations. No problem so far. No more reporters of this kind of problem. So next steps, what will you have to do? Next, please. Basically, we need to adapt our policy of OpenDNSSEC to be the same as in the registry system. Or in the other hand, you can just try to be, if it's possible, to customize this option on the registry system to be possible, be different the TTL of some records instead of inherited of the whole default zone. Another thing that it's important to mention, we are in the process of a project related to replacement of our HSM. We think that it's a good time to review some stuff and testing new models to use in our signing infrastructure, maybe try a new vendor or new setup to be it's better or not. And of course, improve our monitoring system, because on that day that we start to see problem, any tools, any internal monitoring, external monitoring, the DNSCVs cannot capture the problem. In our DSCC and other stuff, you cannot see any serve fail answers. For our point of view, it's all good, all okay, but the point of view of the clients from the DNS receiver server is not good. So probably it's some good approach to do to improve our monitoring. And of course, the public response, we spend a lot of time to produce technical material, training some C-level stuff, to some interviews. It's probably good to have some planning and testing this kind of planning, and because in some crisis situation helps a lot to spend more time in the technical stuff instead of to share some kind of information. And of course, we have to, on an external review report that it's ongoing now, probably we'll be releasing soon, that we'll compare with our technical report, with the external review report, to be more transparent of what happened and to take the course of next action. So because of that, our DNSSEC operation is freezing. If you see, we continue to have 3 DSs on the root zone. So we have just a freeze window until this report should be done, and you can back again on our normal situations. So lessons learned that we had with all of that. Basically, using short TTLs, that was discussed a lot of this week here. Baby steps in all situations, because the situations can always get worse. Just go ahead if you have your own data and you can reproduce. So it's basically that. And that's it. I put a link of our technical report that it's more detailed we have all the timeline of the transition of the key tags of our domains. That's it.
Thank you, Felipe. Very informative, and thanks for being so frank and open about the problem. So you mentioned that one of the main causes was the fact that the old registry and the new registry had a mismatch in the TTL duration for the DS records, and that you also use OpenDNS as your configuration management tool. So I'm not that familiar with OpenDNSSEC. I was just wondering whether would it have been possible for more checks and balances in that tool to have detected that problem? Because I think one of the things I pointed out in past presentations is a lot of the DNSSEC failures that we see in the wild could be prevented by better software and better tooling, right? So when we identify those, we need to close the gaps. So that's my first question. And the second question, before I forget, I'll just slip it in. You mentioned short DS record TTLs would help. So I agree. And one of the impediments has been that a lot of the TLDs out there, I won't name them, have very long unchangeable TTLs. And that, frankly, is an impediment for DNSSEC deployment, because I think more people would deploy DNSSEC if they knew they could back out of problems more quickly. And if they can't do that, that's going to prevent them from pulling the trigger, even if they wanted to.
Yeah, I think it's not an impediment to using short TTL, but in case outage will help a lot. I think this is the idea. Your first question was related to what? Sorry.
I was asking about whether in OpenDNSSEC there could have been better tooling or checks and balances to have detected the DS mismatch situation.
Yeah. In that case, OpenDNSSEC, it's totally possible to do this kind of like some backup stuff related to the keys and to follow the approach. But in our case, we are not prepared to that, because it's a old scenario that we have that we need to update it. It's our to-do list to do, because in this kind of situation we can recover it, right? So it's not an impediment the tool to do this. It's just our scenario actually.
Okay, great. Thank you very much.
Thank you.
We have another question in the chat from Stefan Ubing. In hindsight, could you have found this issue in your acceptance environment?
In what environment?
Acceptance environment, testing environment, you presumably have.
I don't think so. I think not so far.
Yeah, Louis, I can. These are questions for clarity. So the problem was from people out there who had caches that had different memories of what you had recently. So that it's like they were the ones having. In other words, if you start with a cache, you wouldn't have seen it because your cache was clean, probably in testing. I'm trying to guess. The people that had problems were running caches that you had no insight into.
Yeah, the problem is the cache, and that exactly they didn't receive fresh information of the new DSS.
Right. And this is also a question because I just want to make sure I get what would happen. The TTL in the old registry was longer. Was it longer or shorter? I'm sorry, I forgot now.
The old, it's shorter. It's 1 hour.
Okay, so the old keys were disappearing from caches, but the other they were still needed for the data that was still in the cache.
Yeah,
that's what's going on here. Yeah, so yeah, but by changing the TTL, you put out the data that other people could no longer then validate. And so I understand, it's very understandable that this is probably not something you could see through testing. This had to be experienced by folks out there. And we need to take a look at TTL management once again in configuration, and so that, it'd be great to see if we can figure out how to make sure TTLs don't change in a way that does this to operate in operation. Okay.
Thank you. And I think just one thing that could be worth to mention, it's probably in the next rollover operation, do our scenario to use a multi-signer. Could be a good idea to perform some switchover to another sign, and the backup sign start to be the rollover. Because in case of some failure, you are using the another sign and another totally chain,
Thank you very much.
Thank you.